Everyone, welcome to my channel, Coding in the Attic. So today we're looking at lesson 2, creating a search index with dynamic mapping. This is part of unit 10 on searches. And all of this is part of our MongoDB challenge, completing the introduction to MongoDB course within 30 days. So I've just watched a video on how to create a search index with dynamic field mapping, and we'll look at the lab right now. Okay, so we will authenticate using a verification code from the terminal, associating. Okay, this is to identify our thingy, our account. Okay, so they're asking us to log into our account. I've clicked on the link, I've put in the verification code, put on that, confirmed, and then what? Okay, I've successfully configured the profile. Let's move on to the next thing. Okay, so we'll learn how to create an Atlas search index dynamic mapping on the sales collection by using Atlas CLI. Dynamic mapping specify the Atlas search must automatically index the indexable fields in a collection. Okay, we have a data set that contains records from an office supply company detailing orders, product, and customers. Our application is a dashboard for administrators keeping track of sales at our office supply company. We want to add search functionality so that administrators can easily find sales matching their criteria. So what do we need to do first? So we'll create a search index for the sales collection. So step 1, open and edit the index definition file. App search. I guess I need to swap to the terminal. Oh no, app search index using the code editor tab to set the value dynamic to true. Okay, so I'll go back to code editor. Guess I'll go there, and I need to set it to true. Okay, so it's Boolean, so I guess it's easy. So dynamic mapping, we've just seen that it's when all fields are taken into account automatically so that you don't have to select yourself all the fields. And it leaves out, I think, some of the fields that are not really useful, like object ID and stuff like that. So that will be automatically saved, okay. And I can hit Control S, okay. The final file should look like this. Okay, and there is an explanation. What does it say? So the search index JSON file contains the Atlas search index definition. Okay, and here's an overview of the fields defined. So the name field specifies the name of the index as it will appear on MongoDB Atlas. Okay, the search analyzer specifies the analyzer to apply to query text before searching with it. So in this example, we use the default Lucene standard analyzer. Yeah, they did say that the Lucene standard are industry standard for searching. The analyzer defines how Atlas search will turn a string field's content into searchable terms. Okay, so I guess it's how it chops it down to individual searchable terms. Okay, it defines the tokenizer used to extract tokens from the text and filters to use. In this example, we use the default Lucene standard analyzer. Collection name and database define the collection database on which to create the index, which makes sense. And the mapping's object is used to define the mapping to use dynamic or static. And this in this example, we're using dynamic, which means that we want Atlas search to automatically index all supported field types. Okay, accept. So now let's navigate to the terminal. And we need to run the following command. Okay, let's copy this. I'd like to read the entire command. So we've got Atlas cluster search indexes create, cluster name, with my Atlas cluster edu with an F, and that's the file path, I guess. Okay, let's run this. Okay, so it says we've created a sample supply cells dynamic search. Okay. Now we need to verify that the index creation has started. We'll copy this here. I really don't like copying and pasting without understanding what I'm doing. So this is the list. It lists these clusters. Uh, Searches, I guess. Okay, so we've got the one that we've created, sample supplies cells dynamic, the database on which it runs, the collection, the type. Okay. So if the index has been created, we should see a similar output. Yep. Okay, so that means that we've created the index. Okay. Well, nothing really difficult here. We just copied and pasted 2 lines, but they didn't really explain what they meant. Okay, so we've created a search index. Okay. And we'll use now the Mongosh and the aggregation frameworks, specifically the search stage, to use the newly created Atlas search index. So remember that the Atlas search index is the way the information you're providing the search by is divided and interpreted to make sure that your query is best analyzed and the results are the best results. Okay, using an Atlas search index dynamic mapping, in this lab, you'll learn to use the search aggregation stage to perform search queries on the Atlas search index. So we are in the Mongosh tab. Okay, run the following find one command to obtain sample documents. So that's something we're used to doing now. Let's have a look at what the data looks like. Okay. So we've got items, different items, and this relates to a single sale date. Okay. And so let's query the sales collection with a search index to identify documents where one of the fields contains a string notepad. Okay. So in the Mongosh tab, modify the search in the pipeline variable below and run the aggregation pipeline. We need to set text of query value notepad to notepad. Okay. So I guess I need to go to, I need to copy this. Copy it down. And I'm not sure I understand what I need to do. I need to change this. Oh, oh, that's here. Okay. So the query, I need to search for notepads. That's the query. Okay. So text.query value to notepad and text.path.wildcard. What is that? Text.path.wildcard to an asterisk. It's rather enigmatic, to be honest. I'm not really sure what I'm doing, but I'm doing it anyway. Okay, and then cells aggregate. Okay, let's copy now this. The changes that we've just made. Okay, so I think we obtained what we were looking for. Yes. Oh, so many people bought notepads. Okay. It's a bit weird because I've printed this, I've copied this, and then I've got a variable here and the last line of the command here. It seems to have been working, I guess, because I've got the result here, not notepad, and this self date. Same for this one, you've got notepads as well. So I guess I got this right. Oh, that's the aggregation command. Okay. Hold on. I think I should have done this um, differently. Wait. Actually forgot what aggregates mean. Mm. Oh yeah, it's when we were looking for information on our database. Okay, let's have a look at all this. So we do have an explanation here. Okay, so let's say that I can change the values in the code editor and then load the file. Hmm. Okay, I guess this works just the same. I have all the results where you've got notepads in them. Okay. Okay, I think I got this right. Okay, let's look at the explanations. The search is an aggregation stage used to perform a full text search on the specified field by using an atlas search index. Okay. Indexed, also the name of the index we've created. Text is the search operator. Query specified strings. Okay, path specifies a field to search. Set is the underscore field to the result set. Meta is an aggregation operator to return the metadata associated to the document. Oh, this is very complicated. I guess with a bit more practice, I'll understand better all this. Okay, let's see if I've done this right. I did change all this. Yeah. Okay, seems okay. Okay, let's hit the quiz. When using a dynamic index, which fields does an atlas search query against? Uh, Dynamic, it's not just the fields that the user selects, because dynamic indexing means we're actually targeting all the fields. I think it's all the fields. Yep. When would you use a dynamically mapped search index? When you want to search within 3 specific fields, when you want to search for names, when you want to search all the fields with equal weight. I think that's this. Did you tell us about when you're actually mapping it yourself, giving different weight to certain fields? And I think that's not when dynamic mapping is used. Yes, exactly. And that's with equal weight. All right, guys, that's the end of this lesson. Thank you very much for following along. If you'd like to see more videos like this, please hit the subscribe button and the like button to see me in the next one. See you soon.